Hi, kids. Wow, is it nice out? If I was at school, I would actually be using an air track because we're going to be doing an activity called tracking the force. Hence, tracking the force. I know, that's funny. But since we're not at school, I'm going to be using a hover puck, which are pretty cool because if you turn it on, air blows out the back and it hovers. Pretty cool. So if you can find the tracking the force activity, that would be wonderful. But here is my level ground that I have outside. For part one, okay, I'm going to turn the air on, and I'm going to give it a push. I'm going to push it this way, and then we are going to discuss the motion while my hand is touching it, and then we're also going to draw our force diagram for when my hands are touching it. So here we go. Ready? So just while my hand is touching it. Ready? During that part. Wow, is that exciting. Good. Would you like to see it again? Okay, ready? Just while my hand is touching it. Wow, just while it's touching it. Very exciting. Okay. So if we were to draw an FBD for this, a force diagram for this part, I would like you to pause the video and do that yourself. I'm going to draw my force diagram here, and then you can compare it. So again, this is while it is touching, while my hand is touching it. So, all right, and all right, and there you go. Okay, so, and then we'll talk a little bit about this. Okay, so if you look here, okay, your picture should look something like this. Okay, it is hovering. Isn't that nice how my thing is hovering there? And then I have the force of the air holding it up. That's not the fair. That's the force of the air holding up. I have the force of gravity pulling it down. And then I wrote FA for applied force. If you wrote, F Mr. L, I guess that's fine, but, it's kind of rude. Maybe you wrote, if you're talking about, hey, I'm going to talk about the force from you, Mr. Lindenberger. So you wrote F, and then you wrote U underneath there. Again, that's a little rude, but, I guess that will work. But, and it was moving. My V is to the right, and my F net is to the right. That's super important. Okay? So that's part one. Okay? Part two. Okay, remember. Okay, so part two is going to be after it has left my hand. You are going to discuss the motion. So I'm going to give it a push over here. After it's left my hand, discuss the motion. Okay. And then you're going to draw a force diagram for that part. And I will do the same thing on my lovely whiteboard here. So for part two, okay, I got my hover puck. I know it looks just like a hover puck. Remember, I did minor in art. And, okay, those are the two forces. It's moving to the right. And this time, my net force is that. Okay, so let's take a look here. Okay, so how'd you do? Okay, if you look, so here's my hover puck. I have the force of the air up. I have the force of gravity down. This is after my hand is touching it. It's moving to the right. Well, why does it move to the right? Oh, yeah, that's right. What does it take to get something moving again? Well, that's right, nothing. See, look, the net force is 0, so it stays moving to the right. Inertia. Go with Newton's first law. Okay, so that's part two. For part three, we're going to use our hover puck again, but this time I'm going to have it off, and again, it's going to be after I'm touching it. So I'm going to give it a push, and then you are going to describe the motion after it leaves my hand. So ready? Wow, very exciting. Did everybody see it? So very, very exciting. All right, so draw your force diagram for part three, and I will do the same. So this time it's actually on the ground, so I better draw it actually on the ground. Force from the ground. Force of gravity. And then force of friction. The V is this way. And my net force is that way. All right, so let's see how you did. Okay? So if you look this time now, it's the force of the ground holding it up. Okay? And then the force of gravity is down. Let me draw little slash marks so we know that those are the same size. Okay? So then in this case, the net force is going to be the force of friction. Well, hey, look. I was moving to the right, and my net force was pointing to the left. In this case, I was slowing down. Very nice, okay? Now, we're going to make it really exciting. We're going to make a ramp out of this. I know. Super exciting. Okay, there's my ramp. Can everybody see? So this time, I'm going to turn it on. Okay, and I'm just going to let it go. And on the way down, you are going to describe the motion. How exciting. Okay, let me turn that off. So you guys are going to draw your force diagram. Now, this is the part, it's going to be pretty tricky here, folks, because you are going to need to draw an incline. Look. Oh my, I know. And it's going to be hovering. Okay. And then I have the force of the air. And then I have the force of gravity. All right, so how'd you do? Did you do all right? Okay. Now, if you take a look, if I want to find the net force, I have to add those vectors up. How do we add vectors? Oh, that's right, we add them tip to tail. Are those two vectors tip to tail? No, they're not. So we need to move them so that they are tip to tail. So I'm going to move them so they're tip to tail. So now my F of air is here. And right at the end of F of air, I'm going to draw F of G. So I get that plus that. Everybody see what I did? I moved them so they're tip to tail. And then my resultant, my net, goes from where I started to where I finished. Now I drew it dotted there. You can see that. And if you drew it correctly, it actually points down the incline, which is pretty cool. And my V also points down the incline. Okay? So that's part 4. Okay? Part 5 is going to be very, very exciting. Okay? For part 5, I am going to start it on the bottom and give it a push up. And we're going to describe after it left my hand. So ready? So just on the way up, you're going to describe the motion. Okay? So draw your FBD again. Okay? Draw your FBD for part 5, and I'll do the same thing. Wait a second. It's the same FBD. Yeah, I know. So my net force is still going to be pointing down the incline. But this time, my velocity is pointing up the incline. Okay? So my net force is pointing down, my velocity is pointing up. All right. You should be able to do all the analysis questions. Enjoy! Bye, kids! Whoa. Hit stop.